Good day. In this last lecture, we will discuss what is possibly the most widely used application layer protocol today, which is HTTP, which is of course at the base of your World Wide Web. So, this HTTP, this stands for Hypertext Transfer Protocol. It is the network protocol used to deliver virtually all files and other data, collectively called resources, on the World Wide Web, whether they are HTML files, image files, query results, or anything else. Usually HTTP takes place through TCP/IP sockets. That means it uses TCP. So, first thing is that whatever resources which are available today on World Wide Web, overwhelming majority of it is of course some files which are usually HTML files. They may be images, but also increasingly we have a lot of multimedia content on the web, meaning maybe audio files, video files, they are again files, and a large number of applications are also being developed based on web, because the spread of web has been so fast, and that many of service providers would are beginning to give their services through the web, so that the service becomes available maybe 24 hours a day anywhere in the world. And when you want to do that, apart from files, there may be outputs of other programs which are also passed through this protocol, which is the hypertext transfer protocol. So, hypertext, the word text actually came from the original content, which were mostly textually based with hyperlinks, but nowadays a lot of it has changed. So, this is the HTTP hypertext transfer protocol, and what we use to as a client for this HTTP, the HTTP client is our browser. So, this Internet Explorer, Netscape, these are all Mozilla, these are all HTTP clients. So, it sends a request to an HTTP server, also known as web server, which then send responses back to the client. The standard and default port for HTTP server to listen on is 80, though they can use any port. So, the well known port for HTTP is 80. So, a client requesting any server, any HTTP server or any web server, the first request goes to the port number 80. Later on they may negotiate another port number. HTTP is used to transmit resources, not just files. That is another point, because we are talking about resources. A resource is some chunk of information that can be identified by a URL, and so this is the R in URL. URL is universal resource locator. So, the way we sort of, it's some kind of an address for these resources which is universally valid. So, this so any resource which has an URL can be accessed through the web, and of course, it has to be served by the web server. The most common kind of resource is a file, but a resource may also be a dynamically generated query result, the output of a CGI script, a document that is available in several languages, or something else. Okay. Nowadays we have dynamic web pages. A web page may change. So, somehow they are sort of outputs of some programs, that they are also resources. Static files, of course. Okay. So, while learning HTTP, it may help to think of a resource as similar to a file, but more general. As a practical matter, almost all HTTP resources are currently either files or server-side script output. That means some script running on the server. Of course, what you get to see when you are surfing web, sometimes some of the effects, etc., they may also be the output of programs which have been downloaded along with the page, which is running on your machine. That means which is running on the client machine through Java applets and all. So, but anyway, that program actually is coming from the server. So, used to access data on the www, plain text, hypertext, Hypertext means text with hyperlinks, that means links to other pages embedded in them. Actually, these hyperlinks or so-called links to other pages, they are nothing more than I mean, as soon as you click on a link, what happens is that the URL for the page to which it is pointing, that and a request for that page is automatically sent. So, below a clickable, it may be a text, it may be an image which can be clicked below that means whatever be the outer manifestation of this hyperlink. Actually, there is a there is a URL embedded in it, and an automatic request is, and when you click on it, a request is automatically generated. And when such hyperlinks are embedded in a text, that is called a hypertext. Well, apart from plain text and hypertext, you have audio, video, or other things. So, this HTTP functions like a combination of FTP and SMTP in some way. FTP, as it transfers files and uses the services of TCP. So, just like FTP, this is also using TCP, only one TCP connection, unlike FTP, which uses, if you remember, which uses two connections, one for control, one for data. Here only one connection is used. And it is like SMTP, as data transferred between client and server looks like SMTP messages. Okay. So, they have format of message controlled by MIME like headers. HTTP messages are delivered immediately, okay, unlike mail, unlike SMTP. So like FTP, HTTP, I mean the messages are also delivered immediately. So, HTTP is actually very simple. Client sends a request and server sends a response, similar to mail request and reply. Data in the form of a letter with MIME like format. Like most network protocols, HTTP uses the client server model. So, an HTTP client opens a connection and sends a request message to an HTTP server. The server then returns a response message, usually containing the resource that was requested. After delivering the response, the server closes the connection, making HTTP a stateless protocol, that is not maintaining any connection information between transactions. So, that is one important point to remember, that basic HTTP is a stateless protocol. A request has come, it responds and forgets and closes the connection, and it forgets everything about it immediately. Well, that really is good and bad in some sense. Sometimes some web servers would really like to know, or would really like to keep some information, and there are various things like access logs, etc., which may be maintained on the server side. Another common way in which some state information is kept are through cookies. So, cookies is a simple text file kind of thing which is stored at the client's machine. So, what the server does is it writes something about this client's request in a text file in the client machine itself. So, that next time if that same client connects again, then the HTTP server can read that file and can find out what is last visit or some information about it. Okay. That is how, of course, cookies are also sort of sort of breaks down the privacy in some sense, and it is somebody else is writing things in my machine. So, people, that may be a source of breach of privacy or security. So, some people would like to block the cookies also, it is possible to block the cookies. But anyway, the point is basic HTTP protocol is stateless. That means one request comes, once it is serviced, the machine forgets about it. Now, let us look a little bit more into the details of the structure of HTTP transactions. The format of the request and response messages are similar and English oriented. Both kinds of messages consist of an initial line, 0 or more header lines, a blank line, that is a CRLF, that is a carriage return and line feed by itself, and an optional message body, for example a file or query data or query output, etc. So that is the structure. So we will see what each of these areas really contain. The blank line is just to delineate between the header and the message body. Put another way, the format of an HTTP message is initial line, different for request versus response, that is one. Then header 1 colon value 1, header 2 value 2. So the header name colon value, value of that header, that is how the headers go. And then you have the blank line and then the body. So we have initial line, headers, blank line and the body. The initial request line, so this is different for the request than for the response. A request line has three parts separated by spaces: a method name, the local path of the requested resource, and the version of HTTP being used. A typical request line is get slash path to slash to slash file slash index dot html. Okay. So this is a, this is of course an example. So this is a path name to this index dot html file. So from starting from the root, it goes down the directory and subdirectory, etc., to finally locate the resource, which is now here index dot html. And this is a get, that is a, so this is really a request line. And so get is a method, we will come to that later on. And finally it mentions the version of HTTP that is being used. So HTTP 1.0. So this is what is going to go from the client to the server. Get is the most common HTTP method. It says give me this resource. Okay, we will go into a little bit more into the details of get and other methods like post and head, etc., later on. So method names are always uppercase. The path is the part of the URL after the host name, also called the request URI. Okay. So a URI is like a URL but more general. And HTTP version always takes the form HTTP slash x.x 1.0 or whatever. Now we will get into the URI. You see, what we are trying to get is some file located in some site, that is in some web server. So somehow we should be able to contact that particular machine. So somehow we have to indicate the machine. Then we, of course, we have to say what is it that we are doing, what kind of method we are, what kind of protocol that we are using. And finally in that machine we have to give a path name to that file. That path name is necessary because there may be files with the same name in different parts of the directory. So always the path name is necessary. That is, so all this together constitute the URL. So we will look more into the details of URL later. The initial response line or the status line. The initial response line, we have seen initial request line, now we see the initial response line. The initial response line, called the status line, also has three parts separated by spaces: the HTTP version, a response status code that gives the result of the request, and an English reason phrase describing the status code. Typical status lines are HTTP /1.0 200 OK. That means that a request has been received and its response is that it's okay. 200 is the code for it, and it's okay. That means the whatever has been requested would also be forthcoming. Or HTTP /1.0 4 not found. So this is the request response which might have come because for some reason that file that we had were looking for in the request, maybe that was not available. So it says not found. Now what your client or browser would do is that it will read this and then display it maybe in a separate window, I mean a separate page, that the file has not been found or resource has not been found. The HTTP version is in the same format as in the request line, that http/x.x. The status code is meant to be computer readable. The reason phrase is meant to be human readable and may vary. The status code is a 3-digit integer and the first digit identifies the general category of response. So 1xx indicates an information message only, 2xx indicates success of some kind, 3xx redirects the client to another URL. So sometimes you know that somebody may have moved his old site to some new site, okay, that means to some new URL. So what he would do is that he would leave a redirection message in the old site, so that clients are automatically redirected. I mean, those who has the old URL, even if they land up there, they would automatically be redirected to the new URL. So 3xx redirects the client to another URL, 4xx indicates an error on the client's part, and 5xx indicates an error on the server's part. So maybe the client, whatever resource name it has given, it does not exist, so that is a 404 and so on. So that is the status line. The most common status codes are of course 200 OK and 404 not found. OK means this request succeeded and the resulting resource is returned in the message body. 404 not found. 301 that it has moved permanently. 302 means it has moved temporarily, and so on. 303 that means that the resource has moved to another URL given by the location response header and should be automatically retrieved by the client. This is often used by a CGI script to redirect the browser to an existing file. 500 is a server error, an unexpected server error. The most common cause is a server side script that has a bad syntax or fails or otherwise cannot run correctly. Now the header lines, after the initial line, the header lines. The header lines provide information about the request or response or about the object sent in the message body. The header lines are usually in the usual text header format, which is one line per header of the form header name colon value ending with a CRLF. It is the same format used for email and news posting. As noted above, they should end in CRLF. The header name is not case sensitive, though the value may be. Any number of spaces or tabs may be between the colon and the value. Header lines beginning with space or tab are actually part of the previous header line, folded into multiple lines for easy reading. So these are actually the following two header lines are actually equivalent. You may say header 1 colon some long value dash 1a some long value dash 1b, or header 1 some long value dash 1a then some long value 1b. This is just folded. And for net politeness, actually you should when you send in a request, the from part should be included. That means header gives the email address of whoever is making the request. You may or may not, because this might lead to a lot of unsolicited mails coming to you also, or running the program doing so. This must be user configurable for privacy concern. The user agent. Header identifies the program that is making the request in the form program name /x.xx, where x.xx is the mostly alphanumeric version of the program. For example, Netscape 3.0 send the header user agent Mozilla /3.0 gold. Okay, so that is the program version. If you are writing servers, consider including these headers in your response. The server, the header is analogous to the user agent header. It identifies the server software in the form of program name. For example, one beta version of Apache server returns server Apache such and such. Okay. The last modified, the header gives the modification date of the resource that is being returned. It is used in caching and other bandwidth saving activities. Used GMT maybe in the format last modified such day and date and time. And this last modified is important. The point is that sometimes there are some web pages which are seen by a lot of people, and if they are seen by a lot of people in the same organization, one way to conserve bandwidth is through the use of proxies. So, we will discuss about HTTP proxies towards the last part of this lecture. Now, where the page, once it is brought in, a cache, that means it is put in that proxies cache automatically, so that the next person who is under that same proxy makes the request, he gets it straight away from the cache without having to go to the distant location. But then this cache has to be updated regularly. For that, so if there is a modification on the other side, that means if the last modified has value has changed, then you should get a new copy of that, then you should refresh that page. Now, the request line consists of the request type, URL and version, as we have already said. Categorize request message into several methods. Now, about the URL. So, the uniform resource locator, which is the web page or document address, it indicates a method, the host, the port number and the path. Okay. Let us look at this figure. So, first is the method. The method that is used, and this method could be something like if HTTP or even FTP etc., colon slash slash, then the host, and for this host usually we give the human beings usually like to give the domain name for this host, because it is much easier for us to remember the domain name. That is one thing, and secondly, domain name remaining the same, its underlying IP address may have changed. So, anyway, if you give the domain name, what will happen is that first it will go through the resolver, as we have seen when we discussed the domain name system, it will go through the resolver and get the IP address. So, the domain name can be given over here. Alternatively, an IP address can also be given over here. So, IP address, if you give it, of course, it becomes straight away. So, the IP address followed by a colon followed by the port. So, that immediately becomes the socket. The IP address and the port number together form the socket, if you remember. So, we give the method and then the socket. So, when you have gone up to this much, the port, as I said, for the initial request, it is usually at the port number, well known port number 80. So, if you give the host IP address and the port number, so you give the socket, which means that we have indicated or we have specified where to go, the host, first the domain name and subsequently the IP address, so the IP address of the host. By the way, this host must be on a public IP, naturally they cannot have any private IP if they are to be accessed over the internet. So, that is the, and the port, so the entire socket. So, now we have reached the machine and we also know the method to use, and then in that machine we have to locate the resource, which is the path. Path is, I mean, slash, that means you start at the root, then you go right down to the subdirectory where that particular file is present, and then you give the name of the file. So, this is the entire URL. So, this way all the resources which are located in any of these machines which are connected to the internet and have a public proper IP address, all of them can be uniquely specified. So, this is the heart of this is the basically the addressing scheme for HTTP. Protocol used to retrieve the document, as I said, HTTP is the most common. You can also be FTP or Gopher or News or Telnet. So, these could be the different methods which are used in the method part. Host part is the computer where the information is located, given by the domain name or maybe the IP address directly. Port number separated by a colon, and as I said, the default port is 80, and path is path name of the file on the server. Version, current version 1.1, so 1.00.9 they are still in use. Now let us look into the methods in a little bit more detail, since HTTP is such an important protocol, and moreover many applications based on web use these methods directly, so that you can give some program outputs or you can interact with your client through the web. I mean, originally HTTP was not envisioned or envisaged as I mean, it was envisaged as just for locating some resource, just download it and see that text, and later on maybe hypertext and maybe some multimedia content. But as I said, that increasingly the web had become so popular and so many people are hooked onto the web that people started giving services through the web. So naturally all these services through JavaScript, and that is a whole, I mean, we will not have the time or the scope to discuss this and discuss such web services in this series of lectures. So there are methods of doing that, but anyway finally they have to go through this browser client, etc. So somehow they are actually communicating in HTTP at some level. So that is why let us look at the methods in a little bit more detail. So the actual command or request that a client issues to the server. One is, as I have already mentioned, GET. Client wants to retrieve a document, server responds with the contents of the document. Head, client wants information about the document but not the actual document. So just the header part of it is what is needed. Post, client provides some information to the server. Put, client provides a new or replacement document to be stored on the server. Patch, it's similar to put, but only a list of differences to be made rather than the actual new document. Copy, copy a file to another location. Move, moves a file to another location. Delete, remove a document on the server. Link, creates a link from a document to another location. Unlink, delete links created with link. Option, used by client to ask server about available options. So these are all different methods, and we will look into a little bit more detail into some of these, only a few of these later on. Let us now come to the message body. An HTTP message may have a body of data sent after the header lines. In a response, this is where the requested resource is returned to the client. The most common use of the message body. That means you have asked for a, let's say, a web page, that page is here, that content of that page is here, or perhaps explanatory text if there is an error. In a request, this is where user entered data or uploaded files are sent to the server. So this is the message body, the main content which is in the message. If an HTTP message includes a body, there are usually header lines in the message that describes the body. In particular, the content type. Header gives the MIME type of the data in the body, such as text slash or HTML or image slash GIF. So that so that on the other side the client would know, suppose this is suppose some image is being sent on request. So on the other side the client would know that what kind of resource it is. Say it is being told that this is an image and this is a GIF type of image, so that on the client side that particular application or program to display GIF files would be activated. The content length, header gives the number of bytes in the body, that is also there. to retrieve the file at the URL. So, we write something like http://www.somehost.com. So, this is the domain name part slash, and of course, since over here we see that in this request the port number has been left out. So, it is automatically, the default is always port number 80 /path/file.html. First, open a socket to the host www.somehost.com at port 80 and then get that file. Then send something like the following through the socket: get /path/file.html http 1/1.0. So, this is a request. So, you see the sequence. First, you open a socket to the host, which is the web server in this case, which is in this case somehost.com at port 80. Then you put another request, a get request with the file name. So, that part and the HTTP version from some user at somewhere, and user agent you mention, and then you put the blank line. So, this is the header part. The server should respond with something like the following: send back through the same socket http:/1.0 OK, that means the request is granted, and then request is OK, then the date, that means when it was last modified, content type is text/html, and content length is something. And an HTTP, I mean in the body, of course, the body will contain the, maybe in this particular case say a text document which is in HTML. HTML stands for hypertext markup language. So, this language basically, once again we will not have time to go into HTML. What you can do is that you can open any web page and look at the source. You will find that in your browser there is a, if you look at the top menu, then you will be then there is a way of, rather than looking at the final made up version, you can look at the original source, and there you can see the HTML file. The HTML file, it has a number of tags, and these tags help in showing in specifying the format in which, essentially there are other things, but I mean the major part of it is the format in which the text is to be displayed. So, there may be header, I mean format, there may be tags like header, so they are sort of shown in bold. There may be tags to show the background color, the foreground color, the font color, shape, size, etc. So, all kinds of formatting information are there in HTML documents. Apart from that, it is also possible to embed links, of course. Okay. So, this is one example of what an HTML document might look like. First of all, it gives the tag HTML. So, and whenever you have a tag, you must have the beginning of the tag, you must have the corresponding ending of the tag. So, HTML here and HTML here. Similarly, body, then it says something happy new millennium or something, which is a header. It says H1, so which is a header. Then there may be more file contents and etc. So, this way. After sending the response, the server closes the socket. As I mentioned that this is a stateless protocol and the server forgets about it. So, this is an example of what a simple text HTML document looks like. Now, let us look a little bit more deeply into the methods, the head method. A head request is just like a get request, except it asks the server to return the response headers only and not the actual resource, that is no message body. So, this will work very fast. Okay. So, if you just want to know the header and then take some decision whether or not you want to look at it, then you can ask just for the header and not the rest of it. So, it will come down very fast. This is useful to check characteristics of a resource without actually downloading it, thus saving bandwidth and also a lot of time. Use head when you don't actually need a file's content. The response to a head request must never contain a message body, just the status line and header. So, that is the head method, just get the header. The post method. A post request is used to send data to the server to be processed in some way, like by a CGI script. A post request is different from a get request in the following ways. There is a block of data sent with the request in the message body. There are usually extra headers to describe this message body, like content type, content length, etc. The request URI is not resource to retrieve. It is usually a program to handle the data you are sending. The HTTP response is normally program output, not a static file. Okay. So, this is quite important. For example, I will just give you an example. For example, nowadays many utilities, let us say your electric utility or let us say your telephone, you can see your own bill. Suppose the bill has not reached you. So, what you can do is that you can see your bill on the net. So, what you have to do is that so what happens is this, that first, of course, let us say you are a BSNL subscriber, all right. So, the first thing you would like to do is that go to the BSNL's home page. If you know the address, that is very fine, otherwise you can use any search engine like Google or something to get the address of BSNL, and then click on that address, which is really a link, usually a link to the web page. A link to the web page meaning that usually any website would contain an initial, say, main page or index page as it is called, and if you simply give the if you so simply make an HTTP request to the correct server, the main page or the first page or the index page would be displayed first. Okay. Actually, that is an important point, because while surfing we are sort of accessing so many pages in so many different machines. In the URL, as you have seen, that you need to give the in that last part, the locator part, you have to give the entire path name as well as the file name. Now, how do you know? I mean, usually, of course, unless you are very well aware and very conversant with one particular site or maybe a few sites, other than that you will not know neither the path name nor the file name. So, how do you locate it? That is not how people surf. So, what would but what they do is that maybe they know that, okay, this is, for example, in this particular example we were giving. So, we are trying to find our own, let us say, telephone bill which is missing. So, I want to see my bill. So, I will connect to, let us say, BSNL. So, I will somehow find the address of BSNL, main address of BSNL. So, maybe bsnl.co.in or something, and that is where I will go. Now, when I mention that, I have just mentioned the domain name, nothing else. So, which actually means a server, which actually means this domain name would stand for some web server. The domain name, of course, can be translated via the DNS system into the proper IP address, and since it is an HTTP protocol that is run, the default port is 80. So, so up to that much, that means that up to the socket part, that is fixed. Now, what about the rest? Well, the rest is, it is taken for granted that when, if you have not specified something, maybe you are looking, I mean you will definitely be given only that first page or index page or main page of that site. So, you so that comes as a response in the message body in the form of an HTML document, and that gets displayed in that nice format usually by the browser on your screen. Now, of course, so that is the main page. It may contain several things. Apart from, I mean, amongst all that, I find out that if I am looking for a duplicate bill or something, where do I go? So, maybe something would be written over there, say duplicate bill, all right. Where if you take your browser, if you cursor on that, you will see that the cursor has changed, showing that this is, or maybe the color has changed or something has got underlined some way to indicate that this is actually a link. So, when you click on that link, now what does that contain? that actually contain, I mean, as I said, that it says duplicate bill, that is how it is communicating to the user, but underlying this text there is a hyperlink, and this hyperlink contains the path name and the file name, which will take you to the page where you can get information about duplicate bills. All right. So let us say I click it. As soon as I click it, actually I generate a request. Fresh request, where the server socket, etc. Is already known, and now I have given this what this new path name, this is added on to it. So this is a new request. HTTP, of course, being a stateless protocol, first it has shown you the first page and it has forgotten that you actually exist. But then now you have made another request, which now brings a second page into view. Now in that page, maybe you will find that there is a form over there. Who would process the form on the other side? Maybe some CGI script or some other program. We are not going into that part in the server. But before that, whatever information that you have, maybe your name, maybe your telephone number, something you have to enter. So there is a form, you enter that, and then you say submit. Now this submit will have to, I mean, submit sounds very nice to the and user friendly, but then your machine, which was the client so long, now it has to upload some information, the information which you have just typed in, it has to upload that information onto the server. So this uploading of information is may be done via this post. All right. So this is the opposite of get. The most common use of POST by far is to submit HTML form data to CGI script. CGI stands for Common Gateway Interface. So when you send something, this goes in some format, and the CGI is a language where it is easy to parse whatever you have sent and then get the appropriate fields, appropriate values. So what it will do is, what the CGI script will do is that with all this information, it will form maybe some kind of query, maybe a database query to some database, where all the, let us say in our example we were talking about telephone bills, let us say in that BSNL server, where all the bills or maybe at least the current bills are stored. So it will go with the requisite information, form a query, get that get your bill, and then your bill was of course in a database. So now that information has come, that has to be put together in the form of a dynamically generated web page and sent back. So this is a very common way of using POST. So in this case, the content type content type header is usually application / x www form URL encoded, and content length header gives the length of the URL encoded form data. The CGI script receives the message body through stdin and decodes it. As I mentioned, that CGI has the I mean, is specially designed so that such data which are coming in can be easily parsed and all the values retrieved. So this is an this is how POST method is used. So this is how applications over the internet are generally implemented. Here is a typical form submission using POST. Let us say post /path/script.cgi http /1.0. So basically we are actually we are invoking some CGI script, okay, and we have given the address or the URL of the script, and we have mentioned the method and the HTTP version. From, of course, somewhere, user agent HTTP tool /1.0, content type maybe application /x www form URL encoded, content length 32, home is equal to something. So this is a typical form submission. So what the on the other side, so this will be taken and processed. and finally a dynamic web page would be generated and shown. Let us now discuss a little bit about HTTP proxies, which are important for various reasons. One reason we have already discussed, which is that suppose you are in an organization where a large number of people access the web outside, and nowadays of course almost everybody wants to access the web. So, if that is so, and if the same page in order, and of course WAN bandwidth is always costly and WAN bandwidth is always much lower than the internal bandwidth. So, if some page has already been brought in and that page is fresh enough, then you can cache it in the proxy. That is one use of HTTP proxy. There are other uses of HTTP proxy that I will tell you. So, an HTTP proxy is a program that acts as an intermediary between a client and a server. So, instead of a client directly calling the server or directly sending a request to the server, it may only send it to the HTTP proxy. It receives requests from clients and forwards those requests to the intended servers. The responses passes back through it in the same way. Thus, a proxy has functions of both a client and a server. So, it comes in between the client and the server. When a client uses a proxy, it typically sends all requests to the proxy instead of to the servers in the URLs. Requests to a proxy differ from normal requests in one way. In the first line, they use the complete URL of the resource being requested instead of just the path. This of course is important. Actually, if you are sending a request to the original server, then that you have got, the server has got the request, that means you have reached up to that server. Now, you need to simply give the path from the root to the actual file name. Now, you are sending, now the client, instead of sending the request directly to the server, that is the web server, it sends its request to the local proxy machine. So, naturally to the proxy machine it has to supply not only the path, but also the domain name or IP address of the server that it is sending its request to. There is, apart from caching and bandwidth, due to a bandwidth conservation, there is another use sometimes that a proxy is put to. Okay, I mean, you may do it in proxy, you may do it in some other places, also, like firewalls and all. So, which is that in many organizations nowadays, what is happening is that the network is becoming so big that the IP address space, and we have discussed this earlier, that the IP address space is small. So, you cannot give a proper public IP address to all the machines in the network. Maybe the organization does not have so many such a big network. Okay. For example, class B addresses have become very few or almost non-existent these days. So, any decent sized organization will not have a class B address. So, if that is so, you cannot give proper IP address. Now, if you cannot give a proper IP address to the client, how will maybe you can send the request, you can still send the request to the server, but how will the server respond back? Because for responding back, the server has to communicate with you, it has to open the TCP connection. So, for that, on the other end there must be a machine with a valid IP address. So, one way to solve this problem is to do network address translation, and although network address translation may be done at a firewall, may be done at a router, it may also be done at the proxy. That means what we do is that an organization, maybe let us say it is a big organization, maybe 5,000 machines or something, and it has got just one class C address. So, maybe 250 odd addresses. So, what it might do is that it may allot some number of, let us say 50 valid IP addresses to the proxy. So, that whenever there is a request which is being sent by a client, now the client need not be given a public IP. So, the client may be given a private IP which is just private to that network, that does not work outside the boundary of the organization. From that it sends a request to the proxy. The proxy takes up this request and proxies, that means it sends the request out to the world through the intended web server, giving one of the valid IP addresses, and when it gets the response it sort of changes the IP back again to the actual private IP of the machine and gives it back. So, that is another way proxy may be used. A proxy may also be used to sort of keep track of what kind of data or what kind of sites that people in the organization are generally sort of looking at. Okay, this may be good, this may be bad, but anyway the point is that this may be done if you are routing all your HTTP requests through the proxies. So, naturally it has to give the entire URL when it sends a request through a proxy. So, that is there. For example, get HTTP, and then you give the domain name, then the path, then you give the path name, then the HTTP and its version number. That way the proxy knows which server to forward the request to, though the proxy itself may use another proxy. Again, proxies may be, there may be hierarchy of proxies, etc. We are not going into that. As the saying goes, in network programming anyway, be strict in what you send and tolerant in what you receive. Other clients and servers you interact with may have minor flaws in their message, but you should try to work gracefully with them. So, HTTP specification suggests the following: even though header lines should end with CRLF, that is a carriage return and line feed, someone might use a single line feed instead, accept either CRLF or LF. The three fields in initial message line should be separated by a single space, but might instead use several spaces or tabs, accept any number of spaces or tabs between these fields, etc. So, such minor this thing, usually the other side is tolerant of these. So, with this we come to the end of this lecture. Actually, HTTP and this entire gamut of web services has developed in such a manner that this demands a course by itself. Actually, the whole field of networking has grown at a tremendous rate. People usually talk about the say Moore's law for computing, say the computing power and memory capacity, etc. But if you look at the network traffic and the speed at which network has been growing, you will find that this is actually much steeper than the Moore's law. Moore's law by itself is exponential. So, being steeper than Moore's law means that you have a higher base or steeper rate of growth, which is a very phenomenal rate of growth. And this phenomenal rate of growth has spawned a large number of technologies, a large number of protocols, etc., and it is expanding all the time. So, actually we have tried to encompass the basic technologies first of all, that means the lower layers, and just we have touched upon just the core ideas in all the 7 layers, but many of these topics have really grown. For example, we talked about web today, and you can have an entire course on the way web services are given and all the web applications can be developed, etc., etc. We had given only one lecture on network security. You can have an entire course on network security. It has become so important these days because so many of the transactions are being done over the network. So, what we expect is that as time goes on, this ubiquitousness of network is only going to grow, and just as nowadays we are not always careful to maybe carry a pen, because maybe wherever we go we will find a pen. Similarly, the expectation now would be that wherever you go, maybe you can find a network outlet where you can hook in your maybe laptop or palm top or whatever, and through the DHCP get yourself configured and be on the network. And of course, not only people are thinking of putting intelligent machines like your microwave oven or your heater and other things also on the network. Okay, so this is going to be a universally networked world. So with this we come to the conclusion of this lecture. Thank you.